Great, welcome back. So let's discuss Chapter 10. Chapter 10 actually talks about classes and data objects. And at the end of the chapter, it's going to talk about data abstraction or ADT, and we'll talk about that one as well. But the main purpose of this chapter is to understand what is an object-oriented programming or object-oriented development, OOD or OOP. And in fact, this is the methodology which is being used by all in newer programming languages. And historically, we did unstructured programming. Gradually, in 70s and 80s, we moved on to structured programming. And then starting I would say last 30 years or so, the object-oriented programming has really taken off, especially after the internet. So we'll understand how to write a basic class, and from that class, we can create different objects. So main purpose of this particular discussion is what are the classes, and there are different types of members we can declare: private, protected, and public. And especially in this particular discussion, we'll be discussing only private and public, and later on, we'll learn about protected members as well. And how the classes are implemented or being used, whatever the class actually has the framework or blueprint, and how do we use them by using objects. Then there are specific kind of functions we have in object-oriented programming. They're called accessors, mutators, constructors, destructors. So we'll be discussing all of those special functions in object-oriented. We'll talk about ADT, like I stated, and how to implement ADT. And then it also does a comparison. Just like Chapter 9, there was a comparison between arrays and struct. And it gave a good kind of view how we transitioned from arrays to struct, and now we are transitioning from struct to classes. Then there are some principles, information hiding, polymorphism, and all the principles will be inheritance, and we'll be discussing those at the end of the chapter briefly, because each one of these principles will become a separate chapter later on. You'll see a separate chapter for inheritance, separate chapter for polymorphism, and on and on. So we'll be discussing those at the end. And if I want to declare a class, which is a static class, very similar to a static variable. So OOD, object-oriented design, a problem-solving methodology. It's very different from traditional structured methodology. So in the first 9 chapters, what we had structured methodology. So this is a new way of thinking. And when this was introduced, a lot of traditional classic developers, they did not enjoy it because it kind of hides a lot of stuff from them. There's a lot of black hole in this particular methodology, and there are pros and cons to that one. So one of the concept you will hear is something called class in object-oriented development. The class is basically it's a collection of fixed number of components defined by the user. So this is something like an abstract you created, or some kind of blueprint you created, or your own data type you created. The data type did not exist. For example, data types such as employee or customer, very similar to what we discussed in chapter number 9 in struct as well. But this actually is way more powerful and way more useful as compared to structs as well. So first we define a class. The class itself, when it's defined, if you remember from chapter 9 data structure, also when you define a struct, no memory is allocated at that time. When you create a specific variable of that struct, or in this particular case, we'll create a specific object of that class, then the memory will be allocated, and then we can call all the necessary functions and implement it. So there are various members. There are data members, which basically hold the data, and there are members, which are member functions, which are basically methods. Here we call them methods, but they're basically functions, just like any other function we have been using in our programming classes. All right, so how do we define a class? So defines a data type. So this is a data type. Assume you're creating a class identifier. So you would like to have this maybe a house, maybe an employee, maybe a customer, maybe a product or something. So that's a data type you're creating. At that time, because it's a definition, so no memory is allocated at that time. And just like struct, if we use the word struct here, and we had some kind of identifier here, or we defined the data type, start with a curly brace, then all the member functions go here. Member functions and data members go inside the curly braces, and the curly braces close in semicolon. So as you can see, it's a very natural transition from struct classes. In fact, if I just remove the word class from struct, it becomes a struct. So, but in this case, classes has much more than a struct. So class member can be of a variable or function, like I stated. If the class member is a variable, it can hold some data. And if the class member is a function, it is called a method, and it can perform certain tasks. And there are different types of functions, like we saw in the objectives. There's the accessors, mutators, constructors, and destructors. We'll be discussing all of those in next few slides. So if the class member is a variable, it is declared like any other variable, just like you declare, although you can actually declare as a private, protected, or public. But the declaration part itself is just like any other variable, and you do not need to initialize it. In fact, it's a poor practice to initialize it because that value will be provided by the object. And so you basically declare it, but you shouldn't be initializing it. And we'll see how do we initialize in that case. If the class member is a function, the function prototype is listed. Just like if you remember in chapter 6, when we started creating functions, and we had the header or signature of the function above anything else. In that way, those can easily be identified by the compiler. So the prototypes will be listed inside the curly brace of the class body. And function members can directly access any member of the class. So when you're declaring a function within the class, within the body of the class, they can access the data. They can access the other methods, or they can access the other variables as well. All right, so we talked about three categories. The private is member cannot be accessed outside of the class, which means anything you declare, mostly the variables, mostly the data, cannot be seen outside directly. It is hidden. However, you can access the private data through some functions. So those are the functions we'll learn, and we'll create those functions. For example, if you're a bank customer, and you can access your balance, or you can deposit something through certain functions. But the person who's not a member, who's not a part of that particular bank, they cannot access any balances. That's what it means. The members, and also you cannot access them directly through the function. That's also important as well. The public things, public variables or public functions, they're accessible outside. And the protected ones are, you will learn in the inheritance, when we have the superclass or parent class or base class, then the derived or children of those classes, which we'll learn in chapter 12 or 13, those can be accessed by the protected members. And these are just the symbols to represent the different types of data. This is also what's showing you clock type, and clock type can have different functions. These are the data members, hours, minutes, and seconds, and these are the functions, functions which allow us to access, for example, you'll hear the tradition here, and this is not required, but you'll see a lot of setters and getters. Setters, they basically modify the data, and getters basically get the data. And I'll discuss those in my demonstration pretty soon. So once defined, you can declare a variable of that type. Let's say the class is called clock type, and this variable, my clock, is called an object. Okay, or the other name for this particular variable is called instance. So this instance or object, once that is created, the memory is allocated at that time. So again, let's go. Once defined, you can declare a variable of that class type, such as my clock. A class variable is called object or an instance. Okay, just remember that one because it's going to come over and over again. When you basically define a class, nothing was allocated. Same is true in the struct as well. But when you create an object, immediately the RAM actually sets aside the data for hours, minutes, set aside the space for hours, minutes, and seconds. And same thing, if you have two objects, your clock, then you'll have memory for that one as well. Once an object is declared, it can access the members of that class. Okay, so just like struct, we can use the member access operator, or dot. Dot will allow you to access the members of that particular class, because this particular variable this variable, my clock, has an access to what clock type has to offer. However, if the data was private, we will have difficulty accessing it directly. If the data is public, yes, we can access it, but the methods, mostly the methods are public. So those methods can be easily accessed. Methods are basically the functions. So if an object is declared in the definition of a member function of the class, it can access the public and private members if it's declared inside. But if it's declared outside, then it cannot access the private members. And the reason is the private members are private because the data needs to be hidden, especially when the internet became popular. But 30 years ago or so, we wanted to make sure the data is hidden from outside sources. So most of the built-in C++ built-in operations do not apply to classes. Arithmetic operators cannot be used on class objects unless the operators are overloaded. Overloaded is a concept which is discussed way later in our book. Normally, you'll see that overloaded methods, they have a specific syntax, and then you can overload relational operators, logical operators, increment and decrement, and all sorts of operators can be overloaded. So that's not the scope of this particular chapter, but what it's saying is that arithmetic operators, relational operators, and a bunch of other operators are not really applicable directly to these classes. And the reason is because class itself is not a simple X or Y variable. Class has so many different functions and data. So when you try to add, for example, to objects, and you say add student 1 plus student 2, what does it mean? Does it mean add their balances or add their some kind of other information? What do you mean by add? So we have to be more specific. That's why those operators are not really applicable, because objects and classes are not simple variables, they're complex variables. So built-in operations that are valid for objects, member access operator, and the assignment operator. So those are perfectly fine, just like if you remember in struct as well, that was perfectly fine. So here you can see that we have my clock and your clock, and assignment operator is valid. So your clock data will be assigned to my clock. So once we run this code, both of these clocks will have the same data. And class can be automatic or static, just like a variable. Automatic means when the declaration happens and when you exit particular block, it basically destroyed. It basically doesn't exist. Static actually stays alive. Static is created when the declaration is reached and destroyed when the program terminates. The only time it stops working or it basically is not available when you terminate the program or leave the program. So object has the same scope just like variables, and it's not very different. A member of the class is local to the class. Class can access a class member outside the class by using the class object name. So if you want to access, for example, a function from outside, when you declare an object from outside source, let's say sitting in a main function, you have to use the dot or member access operator. So objects can be passed as parameters to functions and return as function values. This is also true in struct. We saw that in chapter number 9. You can pass them as arguments or parameters, and you can return them as return value as well. As parameters to functions, object can be passed by value or by reference. And this is also true for struct as well. When you pass by value, then it creates two different objects in the memory. One was the original one is the copy one. When you pass by reference, then the only one object exists in the memory and both functions are pointing in the same direction. So that's what it's highlighting here. If the object is passed by value, contents of data members of the actual parameter are copied into the corresponding data members of the formal parameter. So it takes a lot of space because some of these objects could be very, very large. Passing by value might require a large amount of storage space and considerable amount of computing time. So if passed by reference, the formal parameter receives the address, the memory address of the actual location. So this one is faster, this one is more efficient, but of course, if you're afraid that you want to keep the original location, then you will not be able to keep the original data and because everything will be overwritten. Pass by reference is an efficient way to pass a variable as a parameter. Problem when passing by reference, the actual parameter changes. So basically it's overwritten. So if you want to make sure the original does not change, then you can use the constant in the declaration, in the parameter declaration. When you put the const, the original one will not change. It will remain the same. All right. Must write the code for function defined as function prototypes. Prototypes are left in the class to keep the class smaller and to hide the implementation. And this might not make too much sense, but it will make sense once we get to our coding part of it. And then you'll see why we are using it. What it's saying is that you want to keep only the prototypes inside the body of the class, and the implementation or the function implementation where you're writing the entire functions, that should be done outside of the class body. So in that way, you have abstraction. You basically have a smaller, manageable class size. So to access identifiers, we use scope resolution operators. To access any one of those functions, I want to access get function, set function from the class, I have to use the scope resolution operator. And again, in a few minutes, this will make a lot of sense to you. And here is just accessing the set time for my clock. And here you can see before executing and after executing. And here is my clock and your clock. And this one is other clock. And it basically looks like it's basically modifying the data by using another object. So once the class is properly defined and implemented, it can be used in a program. A program that manipulates objects of a class is called a client. So if you're using your main function to manipulate or use an object of that particular class, that will be a client or maybe a separate program. When you declare an object of the class, clock type, each object has its own copy of the variables, hours, minutes, and seconds. And these are called instance variable of the class. Every object has its own instance variable of the class. So if you have, let's say, two objects, one is my clock, the other one is your clock, they have their own data set. They have their own variables in the memory. They are not using the same variables. Now, it comes the fun part now. So we have some functions. These functions and this terminology does not exist in the traditional programming, in the structured programming, and you'll see that this kind of terminology only exists here. So if you want to access the value of the member variables, if you want to access the data inside the class, so we use a function called accessor function. An accessor function typically allows you to access the data, which means get the data. So accessor functions are also called getters because you start with the word get. You don't have to, but it basically is a tradition. So you can say get name or get hour or get balance. So those are called getters or accessor functions. And if you want to modify the data, then we call them functions. Those are called mutator functions or setter functions. These functions, they modify the values of member variables. For mutator functions, almost always you pass an argument and there's no return type most of the time. So for mutators, there's no return type and almost you pass an argument to mutator or setter function. In case of getter or accessor, there's always a return type because that's the whole idea. You're trying to get the value. You're trying to access the value. So it always has a return type and almost always has no parameters. Constant function, member function that cannot modify member variables, we use constant with that one. So C++ has no fixed order in which to declare public and private members. I personally like the private members on the top, but the textbook shows the private members at the end. So it's a choice you have to make because to me, the most important thing is the data. So I like to see how the data will be stored in the memory. So I like to see the variables first. But in the book, it's the other way around. You will see the functions are shown above. So by default, all members of class are private unless you declare them as public. In our case, we'll be declaring our functions as public. Now, some functions which are responsible for internal computation, they can also be declared as private. And we'll learn that one in an advanced class, but here we will not be creating private functions. Private functions are basically functions which are for internal computation. They cannot be called from outside sources. In fact, outside source, such as an object, will not be able to call that function and nothing will happen. It will be a syntax error. Use the member access to public to make us something public, and that's exactly what we'll be doing. Now, constructors are, again, special methods, and constructors are very different, sorry, not difficult, different. Constructors have the same name like a name of the class. And constructors never have any return type, not even void. We do not put anything with a constructor. Constructor is a function, but it has the same name, exact same name like the class, and it has no return type. And constructors can receive either 0 arguments, 1 or 2, depending upon the nature of the constructor. So the purpose of the constructor is to initialize the data. So if you don't initialize the data, then it might the data variables inside the class might have garbage data from the memory. So this is for initialization purposes. So you can have two types of constructors: with parameters, without parameters. Without parameters, if you have nothing you're passing, no data you're passing, those are called default constructor. So name of the class is the name of the constructor. No difference whatsoever. And constructor has no return type. Okay, it's a special kind of function which does not exist in the other programming kind of methodologies. A class can have many constructors, and constructor can execute automatically. You don't call a constructor. Constructor cannot be called. It's a special function. It is invoked automatically. So we don't say constructor is called, and that's what it's saying. They cannot be called like functions. Which constructor should be executed? That depends on the compiler at the runtime. So at the runtime, compiler actually evaluates all the constructors. Constructors are functions, and say, okay, which one is the most appropriate one to invoke. A constructor is automatically executed when a class variable is declared. Because a class may have more than one constructor, it can invoke. You can invoke a specific constructor based on how you're making the call, based how the object was created. To invoke the default constructor, like in this case, notice that your clock, we are not passing any arguments. If we do this, let's say hour is 12 and minutes are 30 and 6 seconds are 45, then it's going to look for a constructor with these 3 values. And in that case, there should be a constructor to match this particular argument set. But if you have no arguments whatsoever, like this one, then it's going to call a default constructor. And I'll show you how the default constructor looks like. And it's just showing you the at the time of the creation of the object, you can have 1 or more arguments. And C++ uses type conversion and looks for the best match. Any ambiguity causes a compile time error. So we can have multiple constructors to ensure that at least a compiler has a choice to call an appropriate or invoke an appropriate constructor. And constructor can have default parameters. The rule for declaring formal parameters are the same. Actual parameters are passed according to the same rules. A constructor with no parameters or with all default parameters will be called default constructor. And typically the default constructor is the one when nothing is sent, no data is sent to as a message, as an argument. So if the class has no constructor, C++ provides the default constructor. So behind the scene compiler is going to add the default constructor. And it is still uninitialized, which is not a good practice. We want to ensure that data is initialized. If the class includes constructor with parameters, but not the default, the C++ does not provide the default constructor. So if there's a match already in place, then there's no need to call the default constructor. All right. And called inline initialization can eliminate need for default constructor. It's just telling you some of the benefits of default constructor. And if you declare an array of class objects, the class should have the default constructor. So in this case, we are creating an array of size 100, arrival time, and this arrival time is an object of this type. So we created 100 of these objects, and then each one of these, they have access to hours, minutes, and seconds. Now, what is a destructor? So destructors are functions without any type. When we say any type, it means no return type. And the destructors are also cannot be called. They're invoked automatically at the end of the when the class has completed its final steps. So the name of the destructor is the character, the tilde symbol, this particular symbol. You'll find this symbol right next to number 1 on your keyboard, and followed by the exact name of your class. And because it's a function, parentheses open and close. Typically, like in this particular demonstration, we will have nobody at all in the destructor. What the destructor does, it deallocates the memory which was that particular object was using. So although you can have many constructors, but there can only be one destructor. So a class can have one destructor. The destructor has no parameters. There's nothing you need to pass. The destructor automatically executes when the class goes out of scope. So when the class has been completed its task, then destructor will be automatically invoked. Okay. Now abstraction means separating design from usage. So you put the prototypes in the body of the class and put the definitions or all the other methods, their entire bodies outside. So separating the logical properties from the implementation details. So it can be applied to data and abstract data type that separates the logical properties from the implementation details. So imagine if I'm the project leader, for example, I know what functions and what data types data member needs to be created. I create the abstraction, I create the entire design, then I hire some programmers. I say, you need to implement these functions and you need to appropriately complete all the properties. So that's why abstraction is very helpful, because I don't need to know the details. I can hire somebody by providing the design. It's more like a blueprint. So by default, members of a struct are public. So this is a comparison between struct and class. So by default, member of struct are public, and private specifier can be used in struct to make it private. By default, the member of class are private. So you can see the slight variation here. Struct by default are public, class are by default private. So classes and structs have same capabilities. So classes, I would say, is the enhancement of the structs. So structs, they have limitations, but of course classes can go way beyond than what the struct can do. So definition of struct was expanded to include member functions, like I stated, like many different types of special functions such as constructors and destructors. If all member of classes are public and there are no member functions, use a struct. If no member functions needed, all you have is data, then just use struct. But if you have a bunch of functions, and typically a large, like a customer class will have thousands of functions, very complex, very large. So what are some of the principles? You can hide the details of the operations. That's called information hiding or data hiding. You can have interface file contains the specification details in .h file. We'll not be doing that in this chapter, but if you feel comfortable, if you have done a little bit more programming in high school or other places in C++, if you want to do the specification or design in a separate header file and the implementation in that .cpp file, please feel free to do so. But my demonstration, I'll be just showing you one of them in the same place. In header file, include function prototype and the comments, and of course the implementation will go in the CPP file. So, and of course the implementation file must include the header file for that particular case, just to show you my header file exists and the compiler will look for it. And that's what it's highlighting here, that you should use double quotes to show. If I get a chance, I can show it to you. The only thing is that online compiler Might act sometimes weird, but it shouldn't. But you should be able to separate the header file and the CPP file. Information hiding, a statement specifying the condition that must be true before the function is called, and a statement is specifying that is true after the function call is completed. So it's basically what is the benefit of the information hiding. And this was executable code. I don't need to discuss that one. It's just like if you want to declare your class as a static, the same rules apply where what we did for the variables is the same rule that it actually it will be exhausted when you end the program. Multiple objects of the class each have their own copy of non-static variables. All objects of the class share any static variable of the class. And this is the end of the chapter. So now I'm going to go to the demonstration and share with you. And this particular file is available on our Canvas site. And if you like to look at it, here's my account class. I use the keyword class. This is the variable or name I assign to it. You can assign any name you like. And this is the start of this is the body of the class. The body ends over here with semicolon at the end. Notice that this class is declared above the main function. It needs to be above, because if you're creating a specific object of account type, and that needs to be defined first. So this is the definition of account class. Now, when you create that one, as we studied in the chapter, you have private designation and public designation. And there's a third one, protected designation, because we are not using the inheritance. So we will not be using protected here. So anything public, and you can use the colon at the end, public, these functions can be accessed from outside because these are public. Outside means, let's say I declare in the main, I have this object in the main of account type. I can access these members, these member functions. However, anything declared as private, and you end with a semicolon here, these things are hidden. These are not, cannot be seen from outside. So I cannot access the name, I cannot display the name, I cannot display the balance directly. However, if I want to see the name, I have to have a get name function to see it. Now you might be scratching your head, why do we have to do this way? Because only the members can see the data. And if you create an object of that type, then you're giving the privilege. Imagine, think about adding a customer to the bank. Now that particular customer, they can see only their data. They cannot see other people's data because each object is separate. But if there's no member at all, somebody's not even a customer of that bank, they cannot see any account balances. All right. So here I have get balance, get name. Do I have to say get? No. But it's a tradition. So these are called, we saw in the slideshow, accessors. This is an accessor. This is also an accessor. The second one right there, that's an accessor. I can tell this one is a mutator. This one is a mutator because it's modifying the data. And we'll see how the data is modified. Typically, the mutators, we call them setters. So you have a couple of getters, a setter, and then you have a show method. Show method is just basically going to show, you can call it print, you can call it whatever you like, it's going to show everything, right? So if you're using Visual Studio or some other system, you can always collapse these classes. And this class basically gives you the design. It doesn't have the implementation. Can I put the implementation there? Can I do this? Yes, absolutely. I can simply say display name. This is perfectly legal. It's perfectly legal. But because we want to do that data abstraction, so we hide the implementation in a separate file. So this can be .h file. I'll see if my online compiler allows me to do that. If it does, I'll show it to you. Otherwise, it's going to give some trouble. And then here's my show method here. Now, because this show method belongs to the account, and that's why you say account scope resolution operator and the name of the function. If you're using a Visual Studio or some other software, it's going to show you the drop-down list of all the member functions. And this account is the name of the class. And this show is the member of this particular class. So you use the scope resolution operator to access it. And because this is a void method, so we have put the void right there. And this is the body of the show method. In that body, all I'm doing is I'm displaying the balance and the name of the person. All right. And you can also collapse it. You can see here, the collapse can, especially if you have thousands of classes, you have finished one particular member function, you can collapse it, and then you can continue your work. And here's my get name function. And because this is private data, but the members of this class inside, they can access the data directly. So all I'm doing is return name because that's the nature of that particular function. It's an accessor function. So accessors allow you to return something. And that's why it has a return type. And we have name of the class, scope resolution operator, and get name. And get balance is very similar, return balance. And then setter, like I stated in my discussion earlier, they almost always have argument list parameters because I want to modify the data. What data? The data which is private data. Here's my data right here, name and balance. I want to modify this private data. So the information is being sent from outside. The data is being sent from outside. So name one will be assigned to name, balance will be assigned to balance. And notice that the setter function or mutator function almost always is a void function, doesn't return anything. Okay, so pretty simple understanding. So we have the design of the class, and then we have the implementation of each of these functions. Now, when I come to the main function, I'm creating an object. This is called object declaration of account type, or it's called instantiation. I'm creating an instance or object of account type. You can name this one anything you like. Like here in this case, I'm calling account one. Now, if I try to access the name directly, it's going to give me an error message. Let me show you the error message. It tells me this is private within this context. You cannot access the name. Why? Because it is private right there. Name and balance cannot be called directly. They are private. That's why this is an error message here. However, I can call, and by the way, this particular account one is a default constructor, default object. So it's going to call default constructor. So this one, no arguments or parameters. So it's going to call default constructor. Default constructor, basically, we don't even have a constructor here. There's no constructor. We'll add the constructor just in a bit. So what it does, if we saw in a slideshow, the C++ compiler automatically adds a default constructor, but it has nothing to initialize. So watch what happens. When I say, show me the name of the person and show me the balance of that person in that account, because now I'm using the object with the dot member access operator. By the way, we did very similar thing in the struct as well in chapter number 9. When I run this one, it's going to show me garbage right there. For the name, it has nothing to show, and for the balance, it's just picking up garbage, 10 to the power minus 310, whatever garbage it found in that particular memory. Because this object, when this object was created, it has nothing. In a few minutes, I'll show you, I'm going to add another object with some data in there. Then here, I'm calling the setter method. When you call the setter method, you can pass the data because setter requires name and balance. That's the nature of the setter method. And you pass the data here. Then once the data has been passed, I call the show method, and it should display Jacob right there, as you can see. And if I call the get name and get balance separately, it's shown over here. So now it's working. Okay, let me create another object again. This time I create account 2. And this account 2, at the time of the creation, I'm going to pass a name. And this person is Mary. And this person has a balance of $100.55. All right. Now the problem is I do not have a function or a method to match these two arguments. So there's no constructor. So we'll be adding a constructor here. All right, how do you add a constructor? So constructor is, let me just add a default constructor first. Constructor is the name of the class, exactly what we had of the, it has the same name like the name of a class. So my default constructor does not accept any arguments. I'm going to add the default constructor here. So this will be account, scope resolution operator, account, and here's my default constructor, and I'm going to assign a default value. I will say no name. If the no name is provided at the time of the creation of the object, and for balance, I will say equals 0.0. And if you just want to, yeah, I think let's keep it that way. So now when I do that, and if I call this account 1, and now when I look at the values, I might have better, oh, it says I do not have a matching one. I forgot to do that. Let me come back to that one in a second. Let me show you. Now you can see for the name, it has no name. And for balance, instead of a very large fictitious value picking up from the garbage from the memory, now it has a 0 balance. And this is possible because of the constructor. Let's add another constructor. This constructor has an ability to take two arguments. One is string, and by the way, in the prototypes, you don't need to provide a variable name. You don't need to say nm. If you want, that's fine, but if you do not, that's fine as well. So here, this particular constructor takes two arguments. All right, let's create that constructor here. By the way, constructors do not have return types. That's why we are not writing a void or anything else next to them. And this will take string and m and double balance. And here's the body of this particular constructor. And name equals to nm and balance equals to bal. All right, now we can undo this one here. And I should not get an error message. And there's no error message, but we are not really implementing this second account. So what if I want to implement the second account? Because all we are doing is showing the account 1, not the account 2. So what if I want to show account 2 as well, all the way at the end? So right there, I want to say account 2, show me account 2. So when I run the code, and now you can see Mary is over here and Jacob is over here. So Jacob is account 1 holder and Mary is account 2 holder. So both of them are working. So this is the purpose of your constructor. Constructor basically allows you to initialize values. And my default constructor allowed me to remove the garbage from these variables. Now, also we studied, we saw in the slideshow, there should be a destructor. So destructor, it typically looks like this, tilde symbol, same name like a name of a class. No arguments are needed. How do I declare my destructor? I'll say account and tilde symbol, account, and that's it. Let's run it. Let's see if it runs successfully. It runs successfully. How do I know destructor was called? Okay, let's leave a message here. Destructor is called successfully, just to see if this one really is invoked at the end. Let's run the code again, and there you go. The question is, why did he say destructor is called twice? The reason is because we had two objects. Both of those two objects, account 1 and account 2, they had their own bodies. They had their own memory locations. Once the program exited, both of those have exhausted. Both of those objects have been basically destroyed. And the class memory allocation, which was given in the RAM, it has been deallocated. That's why there's a 2 times. Now, last thing I want to show you, what if I have a count and I have account 3, and account 3 is actually an array? Can I do that? Sure, why not? So if I simply do that, and if I run my code, and now notice that, do I have to count that many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why 12? Because I had 1, 2 plus 10, 12 of these objects. How do I implement this one? Well, again, you can use a for loop to populate it, or you can just take the data from a file or database, but you can see how easily it can be declared as well. All right, I think that's enough for this chapter, and I'll see you later. Thank you so much. Bye-bye.